The word science has got different meanings for different people. Science may be defined as the growth of ideas through observations and experimentation. The subject of science doesn't necessarily has to contribute something to the welfare of human life, although the man has received many benefits from the scientific investigations. The world of science is so vast that the present day scientists and technologists have to group the various spheres of scientific activities according to some common characteristics to facilitate their training and research programs. All these branches of science still have the common principle of employing observation and experimentation. The branch of science which coordinates the research work for practical utility and services of the mankind is applied science. The subject of engineering mechanics is that branch of applied science which deals with the laws and principles of mechanics along with their application to different engineering problems. As a matter of fact, the knowledge of engineering mechanics is very essential for an engineer in planning, designing, and construction of his various types of structures and machines. In order to take up his job skillfully, an engineer must pursue the study of engineering mechanics in a most systematic and scientific manner. The division of engineering mechanics. It may be subdivided into two main groups. One is the statics and another one is the dynamics. Statics is that branch of engineering mechanics which deals with the forces and their effects while acting upon the bodies at rest. Dynamic is that branch of engineering mechanics which deals with the forces and their effects while acting upon the bodies in motion. Further, the dynamics are subdivided into branches. First one is the kinetics and second one is the kinematics. Kinetics is that branch of dynamics which deals with the bodies in motion due to the application of forces, and kinematics is that branch of dynamics which deals with the bodies in motion without any reference to the forces which are responsible for the motion. Our next topic is the composition and resolution of forces. So, in the very beginning of this discussion, first we should know what is the force. So, force is defined as an factor or as an agent which produces or tends to produce, destroys or tends to destroy motion in any body. Just like example, a horse applies force to pull a cart and to set it in motion. Force is also required to pump a bicycle pump. In this case, the force is supplied by the muscular exertion of our arms and shoulders. Sometimes the applied force may not be sufficient to move a body. Like if we try to lift a stone weighing 2 to 3 quintals, we fail to do so. In this case, we exert a force, no doubt, but no motion is produced. This shows that a force may not necessarily produce a motion in a body, but it may simply tend to do so. In a tug of war, the two parties, when balanced, neutralize each other's force. But the moment one party gets weaker, the other party pulls off, in spite of first party's best effort to destroy motion. Next is the effects of a force. It may change the motion of a body. It may give rise to the internal stresses in the body on which it acts. Next, the principle of physical independence of forces. If a number of forces are simultaneously acting on a particle, then each one of them will produce the same effect which it would have done while acting alone. Principle of transmissibility. If a force acts at any point on a rigid body, it may also be considered to act at any other point on its line of action, provided this point is rigidly connected with the body. Next one is the system of forces. So, first we should know what is the system of force, then we will discuss regarding the different system of forces. So, the system of forces, when two or more than two forces act on a body, they are called to form a system of forces. So means whenever the number of forces, like more than one, like two or more than two forces act on a body, then these two or more than two forces will be called as the system of forces. The important system of forces are discussed here. First one is the coplanar forces, second one collinear forces, third one concurrent forces, fourth one the coplanar concurrent forces, fifth one coplanar non-concurrent forces, and in our next page it will non-coplanar concurrent forces, and the seventh or the last one is the non-coplanar non-concurrent forces. Now the question is, what is coplanar forces? The forces whose line of action lie on the same plane, they are called as coplanar forces. Now the collinear forces, the forces whose lines of action lie on the same line, they are known as the collinear forces. Concurrent forces, the forces which meet at one point are known as concurrent forces. The concurrent forces may or may not be the collinear. Coplanar concurrent forces, the forces which meet at one point and their line of action lie on the same plane, are known as the coplanar concurrent forces. Coplanar non-concurrent forces, the forces which do not meet at one point but their lines of action lie on the same plane, are known as coplanar non-concurrent forces. Non-coplanar concurrent forces, the forces which meet at one point but their lines of action do not lie on the same plane, are known as non-coplanar concurrent forces. Non-coplanar non-concurrent forces, forces which do not meet at one point and their lines of action do not lie on the same plane, are called non-coplanar non-concurrent forces. Resultant forces. If a number of forces like P, Q, R, etc. are acting simultaneously on a particle, it is possible to find out a single force which could replace them, that is, which would produce the same effect as produced by all the given forces, then the single force is called resultant force, and the given force P, Q, or etc. are called component forces. Composition of forces, it is basically the process to find out the resultant of the number of forces. The method of finding out the resultant force, there are two methods. One is the analytical and another one is the graphical method. In analytical method, the resultant force is find out by parallelogram law of forces and method of resolution. Parallelogram law of forces, it states that if two forces acting simultaneously on a particle be represented in magnitude and direction by the two adjacent sides of a parallelogram, their resultant may be represented in magnitude and direction by the diagonal of the parallelogram, which passes through their point of intersection. So, mathematically, the resultant force will be R equal to root over P square plus Q square plus 2PQ cos theta, and tan alpha equal to Q sin theta divided by P plus Q cos theta, where P and Q are the forces whose resultant is required to be found out. Theta is the angle between P and Q, and alpha is the angle between resultant force R and force P. Now, if R is the angle between R and Q, suppose alpha is the angle between R and Q, then tan alpha will be P sin theta Q plus P cos theta. So, on the basis of positioning of alpha, the tan alpha may be represented in two ways. Whenever alpha is the angle between R and P, then tan alpha will be Q sin theta divided by P plus Q cos theta, and whenever alpha is the angle between R and Q, then tan alpha will be P sin theta divided by Q plus P cos theta. Now, here some cases are to be followed. What are the cases? Say theta equal to 0, then R will be equal to P plus Q. If theta 90 degree, then R will be root over P square plus Q square. If theta 180 degree, then R will be P minus Q. And the next case is if P equal to Q, if P equal to Q, then R will be 2P cos theta by 2. This is the final form, and if the question arises how it comes, then it comes in this way: as P equal to Q, then in the very primary form R equal to P square plus Q square plus 2PQ cos theta, the whole thing will be under the root over. So R, in this case, R equal to root over P square plus P square as P equal to Q plus 2P square cos theta. If you take 2P square common, then 1 plus cos theta equal to root over 2P square into 2 cos square theta by 2. In next step, here the space is restricted, so I need to erase the whole thing again. R equal to root over 4 P square cos square theta by 2. That will give you 2P cos theta by 2. So this is the way you can find the term R equal to 2P cos theta by 2, in which case when P equal to Q. Now we will take the example. Here two forces act an angle 120 degree. The bigger force is 40 Newton and the resultant is perpendicular to the smaller one. Now what is the value of the smaller one? Then first of all we need to draw the figure. So as per available data, say this is the force, bigger force P, that is 40 Newton, and that is Q, smaller one. The value of Q is to be calculated with the help of the parallelogram law of forces, and as per the parallelogram law of forces, the diagonal OB represent the magnitude and direction of the resultant of force P and Q. And as per available data, the angle between P and Q is 120 degree and the angle between Q and R is 90 degree. So the alpha, if alpha is taken between the angle taken between the force P and R, then alpha will be 120 degree minus 90 degree, that is 30 degree. Then tan alpha will be Q sin theta divided by P plus Q cos theta. So after putting the values of available data like alpha equal to 30 degree, theta equal to 120 degree and P equal to 40 degree, it comes Q equal to the only unknown Q in this equation. So Q equal to 20 Newton. So this is the answer. So the value of the smaller force will be 20 Newton. The next is the resolution of force. The process of splitting up the given force into a number of components without changing its effect on the body is called resolution of a force. A force is generally resolved along the two mutually perpendicular directions. And here one principle is there, and it states that the algebraic sum of the resolved parts of a number of forces in a given direction is equal to the resolved part of their resultant in the same direction. Now, if we try to understand by deriving this principle, first of all, we need to draw the diagram. Say this is YY and that is XX. Two force P and Q. This is Q and this is P, is represented in magnitude and direction by two adjacent sides OA and OB of the parallelogram OA CB. We know that the resultant R of these two forces P and Q will be represented in magnitude and direction by the diagonal OC of this parallelogram. Let OX be the given direction in which the forces are to be resolved. Now draw AL, BM, CN over OX. Similarly, draw AT perpendicular from the point A on CN. In the two triangle OBM, OBM and ACT, the two sides OB and AC are parallel and equal in magnitude. Moreover, the two sides OM and AT are also parallel. So, OM AT equal to ln. Now, from the geometry of the figure, we may find that ON equal to OL plus LN equal to OL plus, as ln equal to OM, so OL plus OM. But ON is the resolved part of the resultant R and OL is the resolved part of force P and OM is the resolved part of force Q along OX. So it may be concluded that resolve part of R along OX equal to resolve part of P along OX plus resolve part of Q along OX. Now, for the sake of simplicity only, the two forces P and Q's are considered, but this principle may be extended for any number of forces. Next one is the method of resolution for the resultant force. The result of a given system of force may be found out by the method of resolution as discussed below. Number 1. Resolve all the forces vertically and find the algebraic sum of all the vertical components, say summation V. In second one, resolve all the forces horizontally and find the algebraic sum of all the horizontal components, say sum of H, means summation of horizontal forces in horizontal direction, and in first one summation of forces in vertical direction. In third step, the resultant R of the given forces will be given by the equation R equal to root over summation V square plus summation H square. The resultant force will be inclined at an angle theta with the horizontal. So in fourth step, the resultant force will be inclined at an angle theta with the horizontal such that tan theta equal to summation of V summation of H. The value of angle theta will vary depending upon the values of summation V and summation H as discussed below. When delta V is positive, the resultant make an angle between 0 degree and 180 degree. When summation V is positive, the resultant makes an angle between 0 degree and 180 degree. But when summation V is negative, the resultant makes an angle between 180 degree and 360 degree. Similarly, when summation H is positive, the resultant makes an angle between 0 degree and 90 degree and 270 degree to 360 degree. Means the theta will lie between either between 0 to 90 degree or between 270 to 360 degree. But when summation h is negative, then the resultant makes an angle between 90 degree and 270 degree. Now we will definitely take example here. One example, say example, a triangle ABC, a triangle ABC has its side AB 40 millimeter along positive x-axis. So here along positive x-axis, sides BC 30 along positive y-axis. BC is 30 mm. This one 40 mm. Three forces 40 kgf, 50 kgf and 30 kgf act along the sides AB, BC and CA respectively. So along AB it is 40 kgf, along BC it is 50 kgf, and along CA it is 30 kgf. Determine the resultant of such a system of force by method of resolution. Now, the system of given force is shown in this diagram. From the geometry of the figure, we may find out that triangle ABC is a right angle triangle in which side AC will be 50 mm. How it comes? As ABC is a right angle triangle, so AB is the base, BC is the height. So, and the angle ABC is the right angle. So definitely AC will be AC equal to root over. So AC square equal to AB square plus BC square. So after solving this equation, you may get the value of AC, that is 50 mm. Now for the space restriction, here no more marking can be done, so I need to erase the already discussed points here. Now from the figure, sin theta will be 30 by 50 mm. So the value of sin theta comes 0.6. Similarly, cos theta equal to 40 by 50, that is 0.8. Now resolving all the forces horizontally, that is along AB, summation H equal to 40 minus 30 cos theta, where theta is the angle between sides AC and AB, that is theta equal to angle A, sorry, C CAB. So this one 40 minus 30 into 0.8, so this is 60 kgf. And now resolving all the forces vertically, that is along BC, summation V equal to 50 minus 30 sin theta, that will give you 32 kgf. Now to know the resultant, that is the magnitude of the resultant, R equal to root over summation V square summation H square, that is summation 32 square summation 16 square, that is 35.8 kgf. So this is the answer. So the resultant force will be 35.8 kgf. And if we take another problem, the four forces are given. One is 20 kilonewton. Another example 2, 20 kilonewton inclined at 30 degree towards north of east, 20 kilonewton. So this is east direction, that is north, west, south. So 20 kilonewton, 30 degree towards northeast, so 20 newton, sorry, not kilonewton, 20 newton. 20 newton, and the angle is 30 degree. 25 towards north, 25 newton, 30 newton towards northwest, towards northwest means it is in between north and west, exactly in between north and west. So the angle will be 45 degree both in north south direction and in west east direction, with the west east direction and with the north south direction. And the fourth one is the 35 Newton inclined at 40 degree towards south of west. This is 35 Newton, 40 degree incline towards south of west. So this is basically the figure. Now find the magnitude and direction of the resultant force. So here you need to resolve the forces along horizontal direction and just get the sum up. Again, resolve all the forces vertically and get the sum up in vertical direction. And after that, as per the formulas, resultant equal to root over summation h square plus summation v square. That will give you the result magnitude of the resultant. And if you put the summation value of horizontal forces and vertical forces in the equation, tan theta equal to summation v or h, that will give you the angle of the that is the direction of the resultant force. So here if you resolve all the forces in horizontal direction, you may get summation h equal to minus 30.7 Newton, and summation v, I just keep the detailed calculation stepwise. You just need to do that one. Summation v positive 33.7 Newton, and the resultant will be as per the formula root over summation v square summation h square, that will give you 45.6 Newton. Now let theta is the angle the resultant force make with the east. It is the angle which the resultant force makes with east. Then tan theta equal to 33.7 minus 30.7 minus 1.098. So theta will 47 degree 42 minute. Since summation h is negative and summation v is positive, therefore since summation h is negative summation V is positive, therefore theta lies between 90 degree and 180 degree. So actual theta will be 180 degree minus 47 degree 42 minutes, that is equal to 132 degree 18 minutes. So this is the answer. Now the general laws for resultant force. The resultant force of a given system of forces may also be found out by the following general laws. There are basically two laws. One is triangle law of forces and the next one is the polygon law of forces. In triangle law of forces, it states if two forces acting simultaneously on a particle be represented in magnitude and direction by the two sides of a triangle taken in order, the resultant may be represented in magnitude and direction by the third side of the triangle taken in opposite order. Polygon law of forces, it is the extension of the triangle law of forces. Means by triangle you can explain, you can find out the resultant of only two forces, as because what? Because of in triangle there are three sides, so out of three sides, two sides can represent the magnitude and direction of only two forces, and the third one will give you the magnitude and direction of the resultant force. So whenever there will be more than two forces and suppose you have to find out the resultant of more than two forces, so in that case, if the polygon law of forces are applied on that number of forces, in that case the polygon law of forces may help you. Now we need to see what it states in polygon law of forces. Here it states that if a number of forces acting simultaneously on a particle be represented in magnitude and direction by the sides of a polygon taken in order, then the resultant of all these forces may be represented in magnitude and direction by the closing side of the polygon taken in opposite order. Say you have 5 forces and you need to find out the resultant magnitude and direction of the resultant of such 5 forces. So in that case, these 5 forces can form a polygon if they taken in order. And now to close this polygon, one new force you have to introduce, as because the five force whatever given to you, that cannot close the polygon, as because they are taken in order. So in that case, the closing side taken in opposite order can only give you the resultant of these 5 forces. Now, the graphical method for resultant force. This is another name given to the method of finding out graphically magnitude and direction of the resultant force by the polygon law of forces. First one, construction of space diagram, that is position diagram. It means the construction of a diagram showing the various forces or loads along with their magnitude and line of action. Second, use of Bose notation. All the forces in space diagram are named by using the Bose notation. It is a convenient method in which every force or load is named by two capital letters placed on its either side in the space diagram. Construction of vector diagram, that is force diagram. It means the construction of a vector diagram starting from a convenient point and then go on adding all the forces victorially one by one, keeping in view the direction of all the forces to some suitable scale. Now, closing side of the polygon taken in opposite order will give you the magnitude and direction of the resultant force and its direction.